Hi everyone. For today's video, we're going to talk about data mining algorithms with in terms of prediction. I'm Janakin Grandoza Bertiz with my fellow groupmates Sarul Jane Vidalio and Cheryl Ossian. So the topics we will going to discuss are Bayesian networks, instant-based methods, linear models, and experiment with Vega. So we will have four topics for today. So first, let's discuss Bayesian network. So a Bayesian network is a graphical model that encodes probabilistic relationships among variables of interest. Bayesian networks are ideal for taking an event that occurred and predicting the likelihood that any one of several possible known causes was the contributing factor. And Bayesian networks are a type of probabilistic graphical model comprised of nodes and directed edges. So Bayesian networks is uh, just like from the word itself, it is a node of networks of nodes connected to each other. And Bayesian network models capture both conditionally dependent and conditionally independent relationships between random variables. And Bayesian probability is the study of subjective probabilities or belief in an outcome compared to the frequencies approach where probabilities are based purely on the past occurrence of the event. So what are the advantages of Bayesian networks? Number one, for example, in visualization, when we talk about visualization when it comes to Bayesian network, the model provides a direct way to visualize the structure of the model and motivate the design of new models. And when it comes to relationships, Bayesian network provides insights into the presence and absence of the relationships between random variables. So you can easily know or see the absence of one relationship between variables to variables. And next is the computation. When it comes to computation in Bayesian network, it provides a way to structure complex probability calculations. Okay, so how to develop and use Bayesian network? So there are at least three things we need to consider in developing or using Bayesian network. Number one is the random variables. Oh, what are these variables? Okay, so what are the random variables in the problem? We must first identify what are the random variables. Number two is the conditional relationship. So, what are the conditional relationships between the variables? Next is the probability distributions. What are the probability distributions for each variable or for each relationship? So, here is an example of Bayesian network. Okay, so consider a problem with three random variables. We have three random variables which are A, B, and C. A is dependent upon B and C is dependent upon B. We can state the conditional dependencies as follow. A is conditional dependent upon B, just like in the presentation, and C is conditionally dependent upon B. We know that C and A have no effect on each other since both C and A is dependent on B. Okay, and next is we can also state the conditional independencies as follows. A is conditionally independent from C since A is dependent from B. So that means A is conditional independent to C. Okay, right? So C is conditionally independent from A since C is dependent to B. So that means automatically it is C is independently conditional independent from A. Next is notice that the conditional dependencies is stated in the presence of the conditional independence. That is, A is conditional independent of C, or A is conditional dependent upon B in the presence of C. Basically, that means that A is unconditional independent to C, since A is dependent upon B in the presence of C. We might also state the conditional independence of A given C as the conditional dependence of A given B, as A is unaffected by C and can be calculated from A given B alone. Okay? And next, we can see that B is unaffected by A and C and has no parents. We can simply state the conditional independence of B from A and C. And you can also write the joint probability of A and C given B or conditioned on B as the product of two conditional probabilities, for example. And the model summarizes the joint probability of A, B, and C is calculated as A, B, C equals A is dependent B times C dependent to B times B. Okay? Okay, so we can draw the graph as follows. Like B is independent to A and C. Now let's move on to instant based methods. So instant based learning methods simply store the learning examples instead of learning explicit description of the target function. And generalizing the example is postponed until a new instant must be classified. When a new instant is encountered, its relationship to the stored examples is examined in order to assign a target function value for the new instance. Instant based learning includes nearest neighbor, locally weighted regression, and case based reasoning methods. Also, instant based methods are sometimes referred to as lazy learning method because they delay processing until a new instance must be classified. So before processing, it waits or it delayed the process until a new instance must be classified. And a key advantage of lazy learning is that instead of estimating the target function once for the entire instance space, these methods can estimate it locally and differently for each new instance to be classified. Okay, so what are the functions of instant based methods? Number one is when it comes to similarity. So similarity is a machine learning method that uses a nearest neighbor approach to identify the similarity of two or more objects to each other based on algorithm distance functions, just like the k nearest neighbor when we if you know that. And the next is the classification. It is the process of categorizing a given set of data into classes. It can be performed on both structured or unstructured data. And the process starts with predicting the class of given data points. And the classes are often referred to as target, label, or categories. And next is the concept description. When we talk about concept description, it talks about much of human learning involves acquiring general concepts from past experiences. This description can then be used to predict the class labels of unlabeled cases. So, what are the advantages and disadvantages of instance-based methods? Number one, the pros of IBM is it has the ability to adapt to previously unseen data, which means that one can store a new instance or drop the old instance. And the cons of IBM is that classification costs are high and large amount of memory required to store the data, and each query involves starting the identification of a local model from scratch. Okay, example of we have here three examples of instant based methods. We have k nearest neighbor, just like I said earlier. We have k nearest neighbor or the KNN, the self organizing map or the SOM, and We have here the learning vector quantization, or the LVQ. Okay, let's first talk about k-nearest neighbors algorithm. Okay, number one, it load the data. It initialize the k to your chosen number of neighbors. For each example in the data, we calculate the distance between the query example and the current example from the data, and add the distance and the index of the example to an ordered collection. We sort the ordered collection of distances and indices from smallest to largest in ascending order by the distances. So when we talk about k-nearest neighbor, we calculate the distance between classes, and which and who's the near is the, and we classify based from the distance. And number five, we pick the first k entries from the sorted collection. We get the labels of the selected k entries. If regression, return the mean of the k labels, and if classification, return the mode of the k labels. Okay, so choosing the right value for k is when to choose the value for k. So to select the k that's right for your data, we run the kn algorithm several times with different values of k, and choose the k that reduces the number of errors we encounter while maintaining the algorithm's ability to accurately make predictions when it's given data it hasn't seen before. And here are some things to keep in mind. As we decrease the value of k to 1, our predictions become less stable. So when we decrease the value of k and we decrease another value of the k, the predictions become more stable. Just think for a minute, imagine k equals 1 and we have a query point surrounded by several reds and one green. I think, let's say we're thinking about the top left corner of the colored, but the green is the single nearest neighbor. Reasonably, we would think the query point is most likely red, but because k equals 1, k incorrectly predicts that the query point is green. So when the k is decreasing, we have a unstable prediction. Inversely, as we increase the value of k, our predictions become more stable due to majority voting or averaging, and thus more likely to make more accurate predictions. So when we talk about the k, the more k is more accurate predictions. And eventually we begin to witness an increasing number of errors. It is at this point we know we have pushed the value of k too far. So when we encounter an error, that means uh, we abuse the value of k, and we also, just like we add the value of k. Okay, in cases when we are talking a majority vote, or the picking the mode in a classification problem among labels, we usually make k an odd number to have a tiebreaker, like 3, 5, 7, 9. So advantages. So what are the advantages of k and n? So the algorithm is simple and easy to implement. There is no need to build a model to tune several parameters or make assumptions. The algorithm is versatile and it can be used for classification, regression, and search. And the disadvantages the disadvantage of the k nearest neighbor is that the algorithms get significantly slower as the number of examples and or predictions